Okay, class, we're going to talk on the platelets, which are also called the thrombocytes. Thrombocytes because they're sites of thrombosis, and thrombosis is clotting. Thrombosis is clotting. The platelets are, LET at the end of the word means little. These are little plates. They're little tiny structures in the peripheral smear. Little tiny structures in the peripheral smear. The usual size we have mentioned of a red blood cell is 6 to 9 micromillimeters. The platelets are 2 to 4. They're the smallest of all the structures in the blood. The smallest of all. The platelets are actually not a cell. They are a piece of a cell. They are a piece of a cell. The normal count, we'll say, is about 250,000 to 400,000 per microliter. If you have too few, you have thrombocytopenia, too many, thrombocytosis. After they leave the bone marrow, they are there about 6 to 10 days, and then a new supply is coming in constantly. You have about a third of them in the spleen, so if you hit the spleen, if it didn't rupture, the platelet count would go up because you would have squeezed some into the circulation. There's no marrow reserve, and it takes about 5 days to produce them. What happens in the bone marrow is this. A cell called a megakaryocyte, which came off a hemocytoblast, starts to get big. It starts to get big and become multinucleated. Then this particular cell starts fragmenting, starts splitting, piecing up in the bone marrow, and then release these little pieces. And these little pieces are called a platelet or a thrombocyte. Each megakaryocyte can piece up in around 2 to 5,000. Now, when it pieces up, it doesn't take the nucleus with it. The nucleus stays behind in the bone marrow and is engulfed by macrophages. Just like erythropoietin was the main hormone to produce red blood cells, thrombopoietin, by the kidney and the liver primarily, is the one that does homeostasis for platelets along with some other interleukins. The job of the platelets is to assist in hemostasis. So the platelets are non-nucleated fragments of cells, as I alluded to, because the nucleus is left behind. I'm not going to worry about the Hyalomere and everything and the Granulomere, but I will say that in the platelets you have certain granules. Remember, granules are stained vesicles. So you have these certain chemicals that the platelets have. Okay. They also have mitochondria, cytoskeleton because they need to do a shape change. They need to do a shape change. So here's a platelet here. That's a platelet right there. Okay. And let's talk about platelet activation. How does the platelet work? Platelet activation. And what the platelet is supposed to do when we put it in hemostasis, which we'll do in another video, is supposed to form a plug. What it is if there's a tiny break in the blood vessel, or even a large break in the blood vessel, the platelet sticks like a cork. It sticks like a cork in the hole until repair can occur. That's what we call a platelet plug formation. So in order to activate the platelets, injured blood vessels release something that we'll call von Willebrand factor and some collagen, and that will activate the platelets. And when the platelets are activated, they will undergo a shape change. The platelets will shape change to try to fit the little hole, so they'll cluster together. Then they'll stick together using ADP. Now in this case, look, ADP is being used different than for energy. See, chemicals can be used for a whole plethora of different reasons. So ADP and something called strombospoindin will act like glue to hold the platelets together to make a cork. And then the platelets will start what we call degranulating. That means taking the chemicals that they had in the granules out to try to help with hemostasis. to try to help with hemostasis. So those are the three jobs they will do. Shape change to fit the hole, stick together to form a cork, and ultimately it'll form a platelet plug formation. Don't get real heavy on this. I put a little story together here to kind of show you how they work. Okay, you never want to form an inappropriate blood clot. An inappropriate blood clot in a blood vessel can fly up through the lungs, clog the lungs up, and death will occur. So one of the major things you want to do is never clot inappropriately. So normally the intact lining cells of blood vessels, the endothelium, which we'll talk about in the blood vessel chapter, lines blood vessels. They produce some chemicals, prostacyclin and nitric oxide. This attempts to keep the platelets from sticking together inappropriately. Heparin and other substances attempt to keep the clotting system from kicking in. And you'll see this once you do the PowerPoint on hemostasis. I suggest you come back and look at this again. Then when the blood vessels are injured, they release von Willebrand factor because underneath the cells they can do that, and something called tissue factor. When that occurs, they kind of activate the platelets. So the platelets will start adhering to that area of the blood vessel, the sub-endothelial surface, we'll say. Once they adhere, then they will start to do their shape change and the other things I mentioned to do platelet activation, ultimately to form a platelet plug. They will then release their granules, and the ADP and thrombopoietin help them stick together. Remember what we said, shape change, stick together. Okay? Now, Plavix, you may hear that on TV. Plavix tries to keep the platelets from sticking together inappropriately. And what it attempts to do is to block that ADP. Again, like I said, inappropriate blood clots can kill you. Inappropriate blood clots can kill you. Okay? Then we get into arachidot. Other words, what comes into play now are the formation of certain prostaglandins. We won't get heavy. And these prostaglandins help with this. Now, when we get into hemostasis, which you'll see in another video, there are three things that occur in hemostasis. When a blood vessel is cut, it will undergo a vascular spasm. Then second will be platelet plug formation, and then blood clotting, coagulation. Now hear what I'm saying. That means coagulation is not the only thing that stops you from letting your blood flow if you get cut. So when the platelets get involved, they're step 2, platelet activation, which you'll see. So that's why I say go back and look at this one after you've done the hemostasis one. So then the platelets get activated and further help in vascular spasm, you'll see. But the platelets also have some chemicals in them that help with clotting. So they actually have a very, even though they're number 2 in the line, they have a pivotal role to help with step 1 and step 3, which you'll see. Okay. So we keep going. Calcium gets involved, is important. Calcium is important in all of blood clotting, and you'll see when we get to it. Okay. Plavix we talked about. Aspirin inhibits some of the prostaglandins, and prostaglandins are important in platelet activation. So that's how aspirin helps with decrease in coagulation. Thrombocytopenia is when you have too few platelets. We have several different kinds of thrombocytopenia. This semester I won't get heavy into that, but just realize that the normal platelet count is 250,000 to 400,000. In thrombocytopenia, you can obviously see that you would have problems with the stoppage of blood flow. There are different kinds. Some are called by drug. Then we have an idiopathic. That's an autoimmune one. And then we have one where platelets just start sticking together. Thrombotic thrombocytopenia. You can glance at these. And just kind of see, these are very common. The idiopathic thrombocytopenia purpura. Idiopathic means no known cause. At the time it first came about, we didn't know it had a cause. Then later we found it was more of an autoimmune. Thrombotic thrombocytopenia. Something happens that makes the platelets just inappropriately start sticking together on their own. And they start causing thrombi. Thrombi basically are blood clots. Thrombocytosis, you could see, could cause you to clot too much. That would be where you had too many platelets. Iron deficiency can do it, inflammation. So again, it's real important to keep the platelet count appropriate. The job of the platelets, again, is to help in hemostasis. Now, I will say this. You would think that you need the platelets primarily when you get cut. This is what I want you to understand now. Listen to me well. All the time, we are getting what we call microvascular breaks. You right now, by just moving around, because you're pulling on your blood. You're moving your arms, you're moving your legs, you're pulling on these pipes, and they're doing tiny little breaks called microvascular breaks. So the platelets have to be working all the time. That's why in thrombocytopenia, let me go back, in thrombocytopenia, what you will see are little blue dots under the skin called petechiae. That has to do with the breakage of blood vessels and with the decrease in platelets. Now, you will see it in other things too, petechiae, but you have to have these occurring all the time. So platelets are needed all the time. Platelets are needed all the time. All right. We'll close here.